there, my name is Nigel Brewitt, and I'm doing this video on behalf of the second year students at Nottingham University who are undertaking a mechanical engineering degree, and one of their assignments is to design a two-stroke engine. And so we thought it might be a good idea, or I and my groups thought it might be a good idea, to get a real life engine, two-stroke engine, and strip it down. So that's what we've been doing, and in the last video I took it down to a certain degree, and now I've actually stripped it down completely to all its component parts, and we're going to have a look at those in detail and discuss their function. Now, I'm not a mechanic, and I'm not a mechanical engineer. I'm a materials engineer, or more specifically a metallurgist, and my forte is failure investigation. So I've looked at components something like this and other things, and tried to decide why they would fail, and that has brought me into contact with the manufacturing processes that made all these things, the materials, the strengths and stresses that are on this component, or all the components. So we're going to do that. We're going to look at each part in detail. I'll lay it out in a linear fashion first, and we'll just discuss it briefly then, and then we'll look at each part in turn. Right, so I've laid it out in this linear fashion here, so that we can describe it from end to end. We'll start at both ends one at a time, and then we'll end up in the middle, which is the most important part of the engine. So at the beginning you've got the pull cord, which was explained in the last video, which of course is a cord wrapped around a pulley, and that is attached to this mechanism, which is also firmly fixed to the crankshaft, which when turned, it turns the crankshaft. We have then the crankcase, or half of the crankcase, and you can see that there is a bearing here fitted into the housing, so you can see, we'll have a look at it in more detail, and this is half of the interface to the cylinder head. We'll talk about that later. See, this one's got a bearing here, fits into this housing here. We have the flywheel that has its cooling fins on, fan blades, or whatever you want to call them, and it has the magnets for interaction with the magneto. And then attached to that we have a clutch, and that is affixed to that part, and that in turn, when the revs are there, will expand to fit into this cup here and turn this drive shaft here. So we won't bother about these end pieces. We'll start to look at the piston and the crankshaft, cylinder head, and the crankcase in a bit more detail. So, well, I suppose first we ought to say something about the flywheel and the magneto. Over here we have the magneto, and you can see that there are 3 pickup points. These are laminated soft iron, and there's a central core inside here which is also soft iron, and when that passes through the magnetic field, you can see it's very strong magnets. When the magnets pass through it, creates a current, goes along the cable to the spark plug, and creates a spark. So we've looked at the thing in general. We've looked at it before. We've looked at the cylinder head externally, and we'll go and we'll actually look at this in much more detail. You can see from this that we've got a sleeve here, a steel sleeve, and yet the casing itself is aluminium. That should give you a clue to which material you should be using. The crankshaft and piston is connected with a connecting rod, the small end, the big end. This is the crank web, and this is the crankshaft itself, with, as you'll see, there is a tapered cone fitting here so that you can slide things onto it, and you've also got the keyway, the Woodruff keyway. I've lost the key itself, I think. I can't find it yet, but that you'll find something like in the flywheel. There is a little keyway here, and so that would fit in that arrangement, and it will stop the rotation. It will also align it, so it's all part of the timing system as well. Okay then, so let's look at that in a little bit more detail. Okay, so we'll look at things in detail now. I've just taken the cylinder head off for a start. Put that to one side, and it'll split the casing, and we'll have a look inside that in a minute. What I wanted to do also is to to start off with, is just to show you the magneto system. This is the flywheel, as we've discussed before, and on it, as we've also discussed, the two magnets. And they're the only two magnets on this one, so they're quite strong magnets, very strong magnets in actual fact, and they're associated with this. This is a magneto, and in this magneto, all it really is a soft iron core. It's laminated, it's made out of soft iron because that magnetizes and demagnetizes very, very quickly. And there are 3 pickup points on it that assembles to the side of the engine and just above the magnets. So as the magnets pass through or pass by the soft iron core, it generates a current, which of course goes along the cable to the spark plug, which is located in your cylinder head. A simple enough arrangement, but it was interesting to just clarify that. So let's start with the cylinder head. Naturally, you've got this place for your spark plug here. This is mounted in the side here. Now you can imagine that that's quite important, really, because this device is taken out regularly in servicing and is either replaced or it's cleaned up, because this can house a lot of carbon. These ends often need cleaning up. These little electrodes, nickel electrode, tungsten electrode there. Spark goes between those two, so the gap is important. We adjust the gap usually just by tapping this in if the tungsten filament has worn away, and we give it a general clean. Also, if you flood the engine, sometimes that happens and fuel gets all over this and wets it, so you take it out and dry it up and do other things, but slot it back again and strike her up. So that's the spark plug as well. The cylinder head has a few features which are quite important in design. Now obviously we've got the fins, which are meant for cooling, and we've been through this on the last video. And you've got your ports, you've got your exhaust port, your you've got a flange face which a gasket goes on, and that will attach over your piston and onto your crankcase. Important things, well, several important things here. One of them is this insert here. This is a steel insert. You can imagine that aluminium and its alloys are very good in many ways. They're good to make castings out of. They're easily castable. They have reasonable heat transfer. It is reasonable in cost. So it's a good alloy. But when it comes to wear resistance, it's not so good. And if you've got a piston that's got cast iron rings on it, and it's constantly rubbing up and down the aluminium, it's not going to last too long. So what they do is they put a liner in, which is made out of steel. This will help in a number of ways. Obviously, it helps with the wear resistance. You can see down there, I hope, you've got the ports. One's the induction port, and then you've got the exhaust port on this side as well, down there, and that's cut into this liner, this insert. So, useful point there. One of the other things that I find was very useful and good observation was, when you assemble things, you've got to put screws into holes and then attach the components together. Now, I noticed when I was taking this apart that this flange, which is held together to the crankcase by these screws, Allen-headed screws, they located into these holes. Now, as you can see, I'm fumbling around here a little bit trying to get it in. That's not just me being clumsy, although part of it is. But it's rather difficult, mainly because there's not an awful lot of room between the underside of these fins and the top side of the Allen-headed screw. So what we do is provide space where you can't normally see it, and for a tool to get in there just straight from here isn't practical. So what they do is design these holes in the fins themselves and go straight through. In actual fact, that's part of the casting. So that gives access for a tool of some kind. This isn't the correct tool, but it can go straight through this these holes and into the screw and unscrew it. So you can assemble this thing and disassemble this thing quite easily. Just take that out. Anything else to say about this? Really, well, probably a very important thing is these channels here are the transfer channels, the transfer ports, if you want to call them that. And they're very similar to what's on top of the crankcase as well. So they match with that. So they will seat on exactly in that position. And you can see that they're angled. Okay. Now they're angled like that because this is the induction side, this is the exhaust side. So if you can imagine that the fuel is transferred to the top of the cylinder, to the top of the piston, in the cylinder head, and it's doing so when this goes down towards bottom dead center. Now, that means that the explosion's happened, that the explosive event has happened, or exhaust gases have been created, and the exhaust gases need to get out. Now, when you get down there, you're asking the exhaust gases to go out and the fuel to come in. So why not make the fuel work for you? If we have this angled and the fuel comes in, it actually goes in this direction towards the induction side. Okay, this is the exhaust side. So when it goes in there and that goes in there, then they push the gases out this way. So they assist in the removal of the exhaust gases through the exhaust port. So let's get on to the crankcase here. We've seen it with the flywheel on, and the clutch mechanism that was associated with that. And now we can split this. There was a gasket in here. I've mislaid it. It's gone somewhere. I don't know. But there was a gasket which would go on this face, between these faces. The first thing to notice about these faces is these dowels, or spigots, however you want to refer to them. And these are location pieces. So that makes it very easy for when you're assembling these things to locate all these holes which you're going to put fasteners in. You can actually locate this by applying the dowels into the holes provided on the opposite side. You can just see that. So now, once those dowels are in, all these holes are aligned with holes in the opposite component, and very easy to screw through. So, okay, you can see here the arrangement of the crankshaft and the crank web, connecting rod and piston. But let's just concentrate on this item first, this side of the crankcase first, because this area here is where you fit your bearing that goes around the crankshaft on this side. Now you'll notice that it's a finely machined housing, and so this casting was made and then final machined to give this housing effect. So you would have made that housing so that it would be rather tight fit, so this would actually be pressed into the housing, which is good, and it will hold the bearing quite firmly, but it doesn't align the bearing, though it does try to. It doesn't ensure alignment. And so you can notice at the bottom of this is a shoulder that's machined into it. And when the bearing is pressed into the housing, it comes up against that shoulder and is stopped. And when it's firmly seated on that shoulder, it is then nice and square to the axis of the crankshaft. Also evident here, down here, is the lip seal, which comes out here. This I am told is called the prolapse. It's like a mushroom, and I'll just poke that out if I can. Okay, so you can see that it's a continuous ring of rubber all over, but inside this is a steel band which is almost like a spring, and you saw how tight it was in the hole, and that will press into the bearing housing, the end of the bearing housing, and form a seal. So that's your lip seal. Now you've got to be careful with these things. There's a couple of things about lip seals. When they start to leak, they can be a considerable problem. Because they're rubber, they are prone to drying out, so if you're not using the engine for a considerable length of time, they might dry out and crack. If they do that, then they have become embrittled, and when the crankshaft starts moving after that, it may wear those away, which leaves the crankshaft able to move inside of the seal, and that puts pressure on the bearing, and that can destroy the bearings as well. But the important thing is that you can suck air into it. You can also displace air out of it, or displace fuel out of it, sorry. So inside the crankcase you're going to have fuel. It comes through the induction port. So move on to this section. It comes through the induction port and into the crankcase, fills the crankcase with fuel, and when this descends towards bottom dead center, it actually squeezes the fuel a bit and pushes it up through the transfer ports. Now, as that's happening, you get a vacuum in here. So the vacuum, when you're squeezing the air, you get the vacuum, and that helps to suck in the fuel from the induction port. If you have a leak, an air leak, then you won't have that vacuum, and it will find it difficult to actually suck up the fuel, and therefore won't provide the necessary amount of fuel to the top end of the piston. So you've got problems. Similarly, if you have a full chamber of fuel and this is leaking outwards, when it pressurizes the fuel like this, it will actually squirt fuel out of the seal, so losing fuel in here, and that will result in lower compression, less pressure to transfer the fuel to the top of the piston. Therefore you're running lean, as they say. So that is bad news. If it can be fixed, but if you persist in using it like that, then it will ruin the whole engine. Okay, so if we take this out, there's the bearing inside its housing. It sinks quite deeply into the housing. It's only just protruding a little bit there, you can see. And also you can just note that this transfer port is continued into this crankcase. With the piston and crankshaft arrangement, you've got your crankshaft. This one has a cone drive on it. It's a tapered crankshaft at the end there. There's a Woodruff key slot there, and that will align with the flywheel, the key in the flywheel, and a little a key way in the flywheel, and a key will go in between those two to align this with the magnets in the right place and all this sort of thing. It'll stop some rotation, but there's no real load on that that Woodruff key. You've got your crank webs, 2 crank webs. The crank pin can't be seen because it's got the big end around it, the big end of the connecting rod to the small end, which is around the gudgeon pin. So just talking about the piston a little bit. This piston is crowned. I'm not sure if you can see that there is I need to be able to get the light right, but there is an arrow there, and that they always put that on, and it always points to the exhaust side. Now, a couple of things about the piston. It has a crowned piston. It is a crowned piston here, so this is slightly radiused. surface here. That apparently has something to do with the flow characteristics, so it produces a swirling motion, which is beneficial apparently. But it also thickens up the center, so you've got a mass there that your flame front hits first, and so it'll absorb that. It also increases the thickness of the crown at a vital point, so that it won't flex at all. Otherwise you'd get a fatigue problem. Your rings here, I'm sure you get fancy materials for these rings, but I'm pretty sure in this case it will just be cast iron. And they are floating in these grooves, these piston ring grooves. And the problems you can have with them is if you get, as you operate, in actual fact this was covered in black. This was black carbon. And that's quite common, but if that carbon goes into these rings, into the ring grooves, it can actually seize the ring in the groove. So if it sees it in here, you can see it becomes flush and it sticks out here. That's not very good, because once it sees it in there, then when you've got the explosion that goes off above the piston, it's going to lack the force on the power stroke, because some of the flame is going to come down here. It also, the biggest issue of course is it doesn't provide the compression. If this piston ring was completely out on both sides and expanded into the piston sleeve, then it would provide the compression. But if it's off to one side, it won't. The other thing is if it goes off to one side, then as this ascends the piston chamber, it will actually rock. If you get it rocking like that, then you can get what they call piston slap. This is when the skirt of the piston actually slaps against the side of the piston casing. Eventually that will result in cracks and things like this, where bits actually fall out. If they fall out, then they can go into the crankcase, into the and end up in your bearings and ruin your bearings. So this is one reason why you should get your oil and fuel and petrol mixture at the correct ratio, and don't use cheap oils. Otherwise you tend to do this carbonizing. The other thing is, if you see, there is quite often a slot cut out of the piston, the side of the piston, and that is so that when it descends to bottom dead center, when it descends into bottom dead center, it still has room for the fuel to transfer through the transfer port. So okay, that's the operation. Hopefully that's been of use. We've talked about the lip seal. Now this casing, crankcase, this is part of it, but this is a sealed vessel here. Outside of it is where we can start to think about cooling. Now you've got the fan on the flywheel, which when connected in here onto the crankshaft can provide some air movement, and that gets its air through this casting itself. So you've made plenty of gaps here, taken every opportunity to provide gaps. You've also provided with ribs here, which can increase the surface area and help with cooling, as well as providing a significant amount of strength. Ribs here will have a dual effect, the cooling and the strength. It's mainly for strength, but it does have that secondary effect of providing cooling. So that's pretty much it for explaining the function of everything that's going off inside the engine. I think I'll leave it there. There's another lip seal on the side of the other side of the crankcase, you see. But I'll leave it there for now, and we'll discuss this further in class. Well, I hope that was of some use to you. It was pretty obvious from the start that you just don't get appreciation of what things are in real life from just SolidWorks models, however nice they are, rotating around and showing you the workings and everything, and looking at schematics and on PowerPoint slides, even if they are animated. Getting to look at something in real life is very important. You can see how they make things. You can appreciate more the function and what is required to make that function a reality. So I hope that all of that was of some use to you, but just bear in mind that all engineers need to get their hands dirty. You can't be a good engineer unless you've actually got in there and looked at things. So when you see components, I don't expect you to go and dismantle your next door neighbour's car or anything like that, but when you have a look at things that are moving around, things that are operating in an engineering sense, have a look at it. If it's old and rusty, take it apart and see what's inside. Try and gain an appreciation of how it works. Why would they make it in that fashion? What was the purpose of that type of design? What materials did they make it out of? Why did they make it out of those materials? And then that will bring you on to considering all the strengths and the properties of materials, of course, but also the properties of good design. So my final message to you then is good engineers get their hands dirty. Thank you for listening anyway.